Hello guys, welcome to Books and Code, and the problem that we are going to solve today is fill the matrix. But before that, if you're new here and a person who likes stuff related to coding, then you can subscribe the channel so that you never miss out an update. So let's get started. The problem statement says that given a matrix with dimension n cross m entirely filled with zeros except for one position, which is x and y, which contains 1. Find the minimum number of iterations in which the whole matrix can be filled with 1. Okay, so how it's going to fill? In one iteration, 1 can be filled in 4 neighboring elements of a cell containing 1. Okay, so let me just take an example in order to explain. Let's take this as our grid. So it is a 2 cross 3 grid. Here n is equal to 2 and m is equal to 3. Now we have a coordinate 2 comma 3 at which we have 1 and rest all are 0, but this is following one based indexing, so I will write one based indexing. So this coordinate is actually going to be this. Now rest elements are 0. What I need to do is I need to make all these zeros as ones and find the number of iterations, minimum number of iterations. So what the rule says is, the rule says that if I have 1 in any of the cell, then I can make this cell as 1 immediately, the cell in the upward direction, then the immediate cell in the rightward direction, similarly for the downward direction and the left direction. So I can make these 4 cells as 1 in one go. So this is something that the problem says. Now what I can do for this problem is I can actually make this cell as 1 and this cell as 1 in first iteration. So iteration count is initially 1. After that, what I can do is with this one I can make this as 1. So I can make like, let me just take green color here. So I'm going to take green color. So I can make this as 1. I can make this as 1, and with this one I can make this right cell as 1. Okay, and at the end we are going to use both these ones, and this will also become 1 now. So how many iterations we have used? We have used total of 3 iterations, like first for this, the second for this, and the third for this. So 3 is going to be my output here. I hope you guys got the clear understanding of the problem. So let me just move to the solution now. Okay, so let me write solution here. Okay, so what we are going to do, let me take an example with the help of which I'm going to explain. So I will have a 4 cross 4 matrix, and I will have x as 2 and y as 2. So what it means is, it means that we have a matrix of 4 cross 4 which is filled by all zeros initially, and only one cell is there which contains 1. And which cell is this? It is going to be this cell following the one based indexing, and this is going to be, this point is going to be 0 comma 0, this is going to be 0 comma n, and this is m, and this is going to be n comma 0, and this is going to be n comma m. Okay, so what we can do is we are going to start from this 1, and from this one we are going to expand the network of ones, where each one will make all its neighbors as 1. So for initially for this one we are going to make this as 1, we are going to make this as 1, we are going to make this as 1, we are going to make this as 1. So it is a kind of BFS because we are doing a breadthwise traversal or expenditure of the network. Like, now these ones are going to make their neighbors as 1, so it will become 1, it will become 1, it will become 1, and it will become 1. Now it will also become 1 and it will become 1. So the intuition behind using different shapes is like, this represent the first iteration, and now triangle I'm going to use to represent the second iteration. And now what about the third iteration? Let's say I will use square for third iteration. So this is something that I'm going to do. Like initially I have as iteration as 1 and now I have 2. So I'm done with the second iteration, and now I'm going to move to the third iteration. And in the third iteration, what I'm going to do is I'm going to make the neighbors as square. Like this will become 1. For this will also become 1. Now for this will become 1. And what about these and these? So they will do the same work, they will make this as 1. Now I'm done with the third iteration and I'm just going to increase my iteration. So after increasing the iteration, what I can do is I can make this as 1 as well. So I will use a rhombus for the fourth iteration. So we'll just draw a rhombus here. So this rhombus is going to be used for fourth iteration. Now since I have all cells as 1, so I'm just going to return my output as 4. I hope you guys understood what I'm going to do here. So I'm going to have a queue data structure which will have storing type of integer array, or if you're C++ coder then you can use here pair. So it is basically going to store the coordinates. After that, what we have is we are going to have a boolean array of n cross m. So we are using extra space here, and what we are actually, why we are using this, because we need to keep track of all the visited nodes. So keep track of all the visited nodes, that's why we are using. So now let me just code this approach, and what I'm going to do is I'm going to write the BFS approach here. So my first step will be to make a queue of a pair type. So it's going to be a linked list. Now I will have a boolean array which is visited of size n and m. Now what I'm going to do is, let me just write like this. Now I'm going to add in the queue a new coordinate. So it is going to be x minus 1 and y minus 1. Why I'm subtracting 1? Because it was following the 1 based indexing and I want the 0 based indexing. So now I'm going to visit it x minus 1 and y minus 1 as well. After that, I'm going to start my BFS. So while my queue is not empty, I need to traverse the current state of queue in one go. So that's how I'm going to do, and I need the size of queue. Okay, so now what I can do is I can have an integer array which is going to be current coordinate, and which will come from queue. After that, what I'm going to do, I'm going to retrieve my x coordinate as the 0 element of this array, and my y coordinate is going to be the first value. So it is going to be 1. Now I need to traverse all the neighbors. So how I'm going to do this, let me check whether x plus 1 is smaller than n or not, and it is visited or not. If it is not visited, then I'm going to visit it, and I'm also going to add it in the queue. So I will do something like this, which is going to be x coordinate plus 1 and y coordinate. So what I'm doing by doing this is, it is basically the downward direction. Similarly, I will write for the upward direction. So let me just copy this and paste this. I'm going to modify this. So now it will become x minus 1, and I will have whether it is greater than equal to 0 or not. If it is not, then there is a problem. And now it is going to minus 1, and it is going to minus 1 also. And I will write upward direction here. So it is the up direction. And now I will do for, let's say, the right direction. So for the right direction, I need to make it as y coordinate plus 1, and it should be smaller than the number of columns. After that, I'm going to write y coordinate plus 1 here and y coordinate plus 1 here as well, and remove this, even make this y coordinate plus 1. Similarly, I'm going to do this for the left direction, and for the left direction it's going to be y coordinate minus 1. Here also it will become y coordinate minus 1, and it will become y coordinate minus 1, and here also it is going to be y coordinate minus 1. Now one more thing that I need is, I need a variable iteration which is initially going to be 0, and each time when I traverse my queue, then my iteration variable increases. So at the end I am going to return the iteration minus 1, because it will count one extra iteration when the queue becomes empty. So it is also going to be counting that iteration as well. So now let me just submit it. uh, First of all, I'm going to compile and run, checking for compilation errors. Okay, so I need to write condition here, so it should be greater than equal to 0. Now let's compile this. Okay, so it's showing basically 3 output and it is correct. Let me just submit it. I hope it should work. So it's working, and now, so it is about the BFS approach. And let me now, so the problem with this approach is it is using extra space. And if I see here the constant of the problem, then it says that I have to use the O of one space. So this gives us an idea that something better can be done. So what that something is, let us see now. What I'm going to do is, I'm going to copy this. Let's copy this and paste it here. Now what I want you to tell is, so this is about the BFS traversal that we have done. And now what I want to tell you is, for the first iteration, what we have done is, we have made all these cells as one. So this was our first iteration. Now in the second iteration, what we have done is, we have made the neighboring cell of these as one. So it became 1, and it also became 1. It will also make its neighboring cell as 1. While making the 1, I'm also taking care of whether my neighbor becomes out of bound of this particular matrix size or not. So that's why I'm not doing something like here. So now let me just make all the neighbors, and here also this is also going to be 1. Now this is the second iteration, so I will cut this. This is going to be second iteration. Now what about third iteration? So it is going to make this as 1, and it is going to make this as 1. After that it is going to make this as 1, and it is even going to make this as 1. So this is about the third iteration. And now for the fourth iteration, what I'm going to do is, this one and this one is going to make this cell as 1. So now we are done. So what actually we are doing is, now I want you to focus here. What we are doing is, for the first iteration I am here, for the second iteration I am here, like I am here. And in the third iteration, I was here, and the for fourth iteration, I have covered only this one. So now what I see is, if I cover these four cells like this one, this one, this one, and this one, then I'm done. Then I can surely say that all these cell contains one. Like let me write this again. Let me say this again. So the statement is, if I'm done with these four cells like the corner cell of the matrix, if I can perform and I'm done with these four cells, then what I can say, I can surely say that the I'm done by with the whole matrix, which now it's containing only ones. So now what I need is, I just need to find this distance. Similarly, I need to find this distance. Similarly, I need to find, let me use the red color here. So first distance is going to be this, the second is going to be this, the third is going to be this, and the fourth is going to be this. Out of all these distances, whatever is my largest distance, that is going to be my answer, because that much time I will need to travel. Like for this one, I need to first go to this one, then this one, so this distance is going to be 2. For this, I will first go to this and then go to this, and this is going to be 2. So you can even recall that how the flow of the program goes. Like initially we have made this as 1, after that we have made this one, after that we have made this one. So it says that in order to make this cell as 1, I need to make this one and this one first. So that's why I'm writing here 2. Similarly, I will write here 1, 2, 3, and 4. So this distance is going to be 4, and this distance is going to be 1, 2. Okay, so out of these distances, sorry, I mean it will be 3, because 1, 2, and 3. Out of all these distances, what we have is, we need to find max of 2 comma 2 comma 3 comma 4, which is going to be 4 only. So 4 is going to be my output. But how to calculate this distance? In order to calculate this distance, what I'm going to do is, I need to let me just erase the extra stuff which is here. So I want to tell you one thing, that this distance is nothing but y minus 1. I mean the number of columns, the current coordinate of 1 is far from the starting index, and this is nothing but m minus y. M is here total number of columns, and it is similarly, it is x minus 1, and it is n minus x. And these distances can help me to find my d1, d2, d3, and d4. So d1 is for 0 and 0, distance of 0 and 0 from this particular point, and after that d2 is for like n comma 0, and d3 is for n comma m, and d4 is for 0 comma m. Now, how to calculate d1? So in order to calculate d1, I need to understand one thing, that from this point, how many total steps we are going to take upward. So we are going to take y minus 1 steps. So y minus 1 steps are the total steps that we are going to take. After that, how many, I mean x minus 1 will be the steps which I am going to take in order to move to the upward direction, like zeroth row. And in order to reach the zeroth column, I need to travel y minus 1 uh, distance. So now this is going to be my first distance. After that, let's see for this one, which is t2. So in order to reach this point n comma 0, what I need is, I need to travel this much distance. Let me use a highlighter here. So I need to travel this much distance. So this distance is nothing but, it is going to be my n minus x. After that, in order to reach this column, I need to travel the same distance y minus 1, which we have traveled before. So after that I will reach this point, and when I have taken these much steps, so I'm sure that I'm at this point. Now for this point, it is the third point, and I'm going to calculate my d3 now. So my d3 is going to be n minus x steps in order to come down, and m minus y step in order to come to the last column. So it is going to be m minus x plus m minus y. I hope you guys are understanding how I'm actually calculating the distance. And let me just now tell you the fourth distance, which is going to be m minus y steps in order to reach this column, this column, and x minus 1 step in order to reach this point. So it is going to be m minus y plus x minus 1. Out of these four distances, what I need is I need to return the max of d1, d2, d3 and d4. So d1, d2, d3 and d4. So now I hope you guys got clear understanding what I'm going to do. So let me just code this approach, and it is really going to be crazy because it is going to be reduce uh, the lines of our program in just a few lines, 4 or 5. So let me just write my d1, which is going to be x minus 1 plus y minus 1. After that I need to find my d2, which is going to be n minus x plus y minus 1. After that I need to find my d3, which is going to be n minus x plus m minus y. After that I need to find my d4, which is going to be n minus y plus x minus 1. Now since I got all the distances, so I just need to return the max of all those, and I'm going to return the stream API in order to do so. So I'm going to make an array of d1, d2, d3 and d4, and I'm just going to take the max of those. Now let me just check whether it's working or not. So okay, so it's working for the sample test case, and let me just submit this solution. Okay, so it's working, and this is about the solution. You can see here I have written only 5 lines of code and it's submitting successfully. So this is all about the problem. I hope you guys like the solution. If you like the solution, then hit the like button. This is all for now. Thank you.